We have the part of engineering polymers, composites, and specialties for medical application. So I would love to present today regarding the topic of composites and for sure the special of recycling of carbon fiber material. Within that, recycling and also with different parts and group companies where we are producing parts or being a first-tier supplier to OEMs. Right now, the Mitsubishi Chemical Group is covering the whole process chain for composite materials. From the beginning of the polyacrylonitrile, producing a carbon fiber material, producing a variety of intermediates, and also we're having in Europe over here the possibility to produce parts with our group companies CPC in Italy and Vetje composite materials in the southern part of Germany. And for sure, this is a focus, or with these parts, we are focusing on the OEM industry. And right now, after the acquisition with the recycling topic, for sure, we can also take care about the recycling solution. This is a major topic. It's becoming more and more in focus, not for the climate change we are heading or having some reduction and sustainability issues. Also, what we learned from the previous presentation, that we probably will end up in a shortage of carbon fiber supply. And therefore, also recycling is an interesting topic I would like to show you. So beside all these advantages, I don't need to explain to you, we need to take care about the recycling solution. Where we are from, we are coming from the waste disposal industry as a service company. The former shareholders used to be a family-owned business in CFRP recycling, or not in CFRP, in recycling service, offering recycling service for household waste or different waste materials. And in early of 2008, actually, we started to take care about the CFRP recycling solution. In 2011, we launched the first industrial scale facility based here in Germany, where we could handle a huge amount of CFRP waste materials. Still in the DNA, we have the waste disposal service company. And this is very good because this is the first important part we need to take care, because whenever companies want to get rid of the CFRP materials, they need to be shipped, transported, and handled in a certain way to get these material prepared for the recycling process. So when we started in 2008 and launched our facility in 2011, we had our major pillars we were focusing on. The first thing was we need to skip the name of recycling. So today, everybody is speaking about recycling and wants to have sustainability within their materials and products. But as I said, when we started a decade before, recycling was not very sexy. So we were focusing on avoiding the name of recycling and focusing on being 100% customized. Being 100% pure means that we can recover the carbon fiber for 100%, and in the same way, doing 100% recycling by using this process. Today, within the Mitsubishi Chemical Group and being part of it, we are very proud to be a major part of supplying solution regarding material streams for other, we call it technology platforms. So our idea is that we will use these recycled carbon fibers, beside virgin carbon fibers, to use them in a different way for the thermoplastic application and the thermoset application. I will go through that later on. But having in mind that we all need to cover by a circular economy approach. So not only taking care about these materials at the end, also right from the beginning, means during sourcing, taking care about different areas where to source and how we can source different material supplies. We need to convert it in a variety of materials. And at the end, it needs to be machined very efficient. And during the consumption means, and our customers who are supplying us with the waste material, we can consult them, we can help them how to treat the CFRP materials in a certain way regarding the waste disposal. So yeah, as I just mentioned before, we are based in the northern part of Germany, very close to Hamburg. And this is not only a good area to do the CFRP recycling, this is beside that also a nice area to live there, making holidays there. And beside apples, we have a river over here and nice beaches. So this is where we are coming from. And yeah, as I said, beside that, we have established established site for handling waste materials. This is due to the fact of our former shareholders, an area where you can see typical orange trucks. In Germany, the trucks from waste disposal management and waste disposal service are typically orange. And the advantage is that even after the acquisition, we're still keeping our site over here because it has all the permissions and certification for running such kind of recycling process. We have the chance, and this can be done very easy to increase our capacity. And we are very well connected over here via a network where we can use the existing CFRP network, which is around aerospace and automobile industry and business. And we are very close to the offshore industry, where we also need to take care about the waste disposal of the wind blades, which are coming to end of life. So how is this recycling working? I would like to guide you through our processes. So we don't care whether the material is coming from end of life, from crash cars, or from wind energy areas from end of life, for example, from the bicycle industry, or if it is a post-industrial waste material. Our challenge was to take care of all of these waste, and when we established that business, the process of design of our facility need to take care about all of these materials. So, and yeah, in the early stage when we started, everybody was talking to me and saying, okay, you are handling the black gold now. And then I'm normally showing this picture because it didn't really look like a black gold in former times, and not even today, because waste is still waste. Even if there are some valuable carbon fiber inside this waste materials, we need to treat it quite well and quite hard to get the pure carbon fiber out of that. How are we doing this? I prepared a small movie where I would like to guide you through our process and what we are doing. And I hope this is also working. If not, please give me a sign. Otherwise, I will keep that running. So in this case, you could see a typical end-of-life waste material, a bicycle frame. It includes painting, coating, different materials, aluminum inserts, and thermoplastic inserts. So a mixture of everything. The process is a pyrolysis process, means we need to avoid any oxygen. All the plastic material is getting not burned because we are avoiding oxygen. So all the materials by a chemical thermal treatment and reaction, all the plastic is going over into a steam phase. And this is a very good advantage because beside this pure carbon fiber, which will be bagged, we can use this pyrolysis gas to heat this process itself. Makes it very efficient, so we don't need to add additional heat by running this process because it all comes from the energy of the resin, which is around the fiber. So this is the setup. You can see on the left-hand side is the open process, and on the right-hand side is the flue gas treatment. So due to permits and laws we have here in Europe, we need to take care about a couple of things and zero emission. And at the end, the pure carbon fiber is back, and you could see it's very clean. There is no pyrolysis, so to say, ash or pyrolysis char left on the fiber. Is a pure carbon fiber material. Yeah, just two pictures before and straight after the process. And you probably can imagine that this used to be a very hard job in 2011 to sell such kind of material on the right-hand side. And you can imagine that the challenge was more to produce a proper product out of it and adding some characters and properties, which brings us to a product we can sell to the market. First of all, what we did is checking the quality. So a couple of recovery processes around the world are available. This is very good because it helps to making recycling more and more common. And on the right-hand side, you could see the fiber surface of our recycled carbon fiber material by our process. So it's very important to have a high quality, no degradation, and this without any pyrolysis char left on the fiber. This makes it much more easier to find new application because the quality is very high. Some information regarding this, we call it waste hierarchy here in Europe. We need to take care about this being efficient by treating and doing the recycling process. So we have this kind of pyramid, means starting with the prevention of waste is for sure, and I would say common understanding, the best way how to deal with waste materials. And the disposal, just bring it to landfill. In Europe, actually, this is not allowed anymore for waste materials, which are including some organic parts. So we need to focus on the recycling and repurpose project. And as I just mentioned, we are running the pyrolysis process. You could see this is a very high and efficient process for recovering the carbon fiber material. So this is all covered by a law in Europe. We need to manage and we need to handle. But at the end, the circle is closed. And for us, this is a circular economy, means coming from an end-of-life waste material from a bicycle frame, for example. Our approach is to bring these recovered material back to the bicycle industry again. How are we doing that? This is on my next slides I prepared. So first of all, as I just mentioned, we need to take care about the high quality, means the mechanical reinforcement of this recovered carbon fiber need to be on the same level like a virgin material. This is what we could figure out and solved already. So customer is asking for specific length. So it depends on the application. In some cases, we need to take care about the sizing, very important point, whether we're gonna go to a thermoplastic application or a thermoset application at the end. And for sure, the availability of large amounts of carbon fiber, recycled carbon fiber material is very important to our customers. And with the, let's say, technology platforms I mentioned earlier by Mitsubishi Chemical. So right now, our approach is to different intermediates, like we call it Chiron Max, so carbon fiber reinforced thermoplastic material, or Chiron Tex, a textile structure, which is mixed up with thermoplastic fibers and can be used directly. Our approach is to deliver to all these intermediates also a recycled carbon fiber or even a recycled polymer. On the right side, we are talking about the thermoset applications. Therefore, we are talking about the carbon fiber SMC, sheet molding compound material, or the prepreg material. And also for these both potential applications, we are trying to use internally recycled carbon fiber material by producing, for example, some kind of non-woven mats, which can be fed to an SMC line or a prepreg line, for example. So a very high approach of sustainability. This is what we are covering right now and what is the strategy from Mitsubishi Chemical. What is behind that? For sure, as I just mentioned, not only saving raw material, being sustainable and making sure that the supply of such kind of material can be secured. For sure, it's also the ecological part of the recycling process. And we found out that compared to the virgin fiber production, for sure, this is not covering what is right now under development, what we just learned from the previous presentation, but coming from the normal pen-based carbon fiber compared to the recycled carbon fiber, we are 1/5 to 1/4 regarding the global warming potential in kgs of carbon dioxide. So whenever a customer is using the recycled carbon fiber material, on the one hand, produced some CFRP waste, on the other hand, we could close that loop and we have a net credit by using these kind of materials. Our portfolio is very large, so we cannot only feed our own intermediates within the technology platforms. For sure, we can also bring these materials and sell them directly to the market as a milled fiber, a chopped fiber, or a resized fiber ball, which are normally used for reinforcement of thermoplastic materials. And then in the second row, you could see the reinforced carbon fiber reinforced compounds with recycled material, and also the nonwovens and very paper-based process material we can supply to customers today. Yeah, some ideas of application. We call it the application with added value. So it's not only that we are using a recycled carbon fiber, using instead of glass fiber materials or just for lightweight. No, we have added value. For example, having an improved surface. In this case, we could also show that we have faster cycle times due to the thermal expansion of the carbon fiber material. It was much easier, and we could go down in cycle times by reinforcing these polyurethane material with our recycled carbon fiber. And this is the added value, where we have cost savings during the whole production and the process of these parts, not using one material A, using a recycled material B instead of it. The mat, the carbon fiber mat I just mentioned before, our non-woven material, we could add some vinyl ester resin, for example, put it into the mold, and then over here is an example for a drilling template, which is in use, which is a lightweight application compared to an aluminum template. Corrosion is a big topic, and therefore the carbon fiber material with the electronic conductivity can also help to avoid corrosion. In the example 1, there's a carbon fiber reinforced nylon 6, and in example 2, there's a glass fiber reinforced nylon 6. So it's not only the mechanical reinforcement of an advantage of carbon fiber material, is also the electronic conductivity we can take care of. Lightweight for sure. Just one idea of the application, you could see on the right picture our carbon fiber veil on a honeycomb core. And this normally need to be shifted and grinded 6 or 8 times. And with our thin veil material, it just need to be grinded and shifted once for having these very smooth and homogeneous surface of that material. Yeah, we are also involved into a couple of government-funded projects, and I would like to highlight this one over here. This is a project we are doing together with the company Composite in Ireland. And it's very interesting because this is an underwater turbine producing electricity in rivers, for example. And the foil, probably you can see the black areas, the black foil over here. This is now produced with our recycled material. And the interesting idea behind this is that we are collecting waste from wind energy, for example, the rotor blade, doing the recovery of the carbon fiber from end-of-life wind blade from wind energy, and now adding over here the recycled carbon fiber for another underwater turbine for green energy production. And then last year we could also, actually this was this year, sorry, we could launch some press release where we could show up a single source waste stream management with Covestro. The job was here to take care about that waste from Covestro, converted into a product Covestro, the same company, can use in that way. So single source is also a very interesting topic, having a circular economy in-house. Yeah, so that makes the circle round, and coming to my last slide over here within this presentation. For us, it was very important since the beginning in 2008 to have a really close loop of such kind of material. I guess even today it's becoming much more important. We have many discussions about the carbon fiber material. It can drive the not only lightweight, it can also drive on the same way taking care about the climate change in a positive way. And we can say our contribution is that we can handle different areas, different materials coming from end-of-life parts, and having really our own applications where we can use recycled carbon fiber materials. And right now I'm looking forward having that discussion with you and being free for any questions. Thank you very much.
Hey, thank you, Tim, for sharing with us about your company and its capability in the composite and recycling area. Thank you. We do have 7 or 8 minutes for question and answer. Let me just read the question through the chat. The first question is, what is the typical distribution of fiber length after and pyrolysis recovery? How well are you able to maintain the original length of fiber?
That's a very good question. What we are doing, we are beginning with the kind of pre-treatment of the parts and the CFRP waste materials. Means, for example, staying with a wind blade, with a rotor, or with a blade from a wind mill. For sure, we cannot handle that 60-meter long blade at once. So we need to prepare it, we need to pre-cut it. You can say shredding, but it's not really a shredding. So at the end, we have a guaranteed length of a minimum of 100 millimeters. So that means we have far enough fiber length to use that for mechanical reinforcement. For sure, we cannot recover endless, but it's a certain length where we can even produce non-wovens, so means textile structures, but it's also for sure long enough to have a proper mechanical reinforcement in thermoplastic application.
Thank you, Tim. Another question, to facilitate the recycling, should there anything we can do from at the very beginning in terms of the design of carbon fiber and also the design of making composite?
Yeah, I love that question as well. So the so-called recycling or design for recycling, it's very interesting. I would say yes and no. For sure, we need to take care about designing parts which are more covered or more produced by thermoplastic materials and having injection molded parts instead of, let's say, metal parts, for example, or aluminum parts. For my understanding, yes, it makes sense to think about that if we can have a design where assembly is probably much easier, or actually the disassembly in this case. And whenever this is a plastic material, we don't care with the pyrolysis process whether it is, for example, a thermoset or thermoplastic material. The process is very efficient, taking care about both materials. So therefore, I would say the advantage of using reinforced plastics instead of aluminum or metal inserts, where we also have hybrid structures, it's much more easier to take care about the recycling. And this is also the approach for using more lightweight materials. So my understanding is composite materials will help out in this. Having special ideas of where to take care about design for recycling, it's very hard to answer that question. It's more up to engineers, but I would say we need to take care that we can disassemble these materials easier compared to other materials. This can be probably one idea.
Thank you, Tim. How is the zero emission achieved for pyrolysis process? Where does the metal go?
Mm-hmm. The metal will extract before. So during the pre-treatment process, we have a magnetic absorber. If there are some non-metal inserts after the pyrolysis process, we can peel them off by a sorting and separation system. Because then normally the structure is very free flowing, as you could see probably on the picture with a bicycle frame. It is easy to get these non-ferro metal inserts away and separated. So it's not really a big issue. The zero emission we can achieve by using the pyrolysis gas to heat the process itself. So normally the pyrolysis gas has about 30 megajoule, which is far enough to heat the process itself.
Thank you, Tim. As we know, finding suitable outlet for recycled material has been difficult in the past. What what increased in the demand for recycled material you experienced over the last 2 years?
Actually, this is fantastic because now you can feel what made me a headache over the last years. It's really to find application, because when we came on the market with the CarbonX brand, a carbon fiber of the next generation, this is the story behind. It was very hard at the beginning to sell these kind of recycled carbon fiber, even if we could show that this is comparable to virgin material, for sure not endless, but comparable in a short way. It was hard to motivate people to give it a try to use it. Up from that stage that we could go further one step in the process chain, for example, showing that we can offer reinforced compounds for injection molding. Nobody was asking whether it is a secondary raw material inside that compound or virgin carbon fiber inside that compound. At the end, you could compare such kind of compound A to compound B. That was much easier. So I would say the breakthrough was for sure that we needed to go one step further in the process chain of producing composite parts. And right now, with the acquisition by Mitsubishi Chemical, for sure, we can even use that material in-house, producing parts, and show that these parts have certain qualities and properties.
Last question before our breakup room. Tim, can you explain how the fiber of recycled carbon fiber is made? Do you use lots of binder? If yes, how much?
I cannot explain in detail, but we figured out how to resize short carbon fibers. It's working quite well. We are not using as much binder. It's a typical 2 or 3% of solid binder content we are using.
Thank you, Tim.
Thank you.
Let's give Tim a round of applause. Thanks.
You're welcome. Appreciate it. Thanks a lot.
So